So in this video, I'm going to be showing you guys how to create a cutting tool for your Fangling plasma cutter or CNC controller. So this is for the Sheetcam. We got to actually define tools here that we're going to be using for our cutting tools. So we need to create a tool to actually cut our drawings when we do import them. So this video is going to just cover on how to create this tool. You can see that I've already created one, but I'm going to go ahead and show you on the process on how I do it. So I'm going to go ahead and show you guys my cutting speed reference table. As you can see here, I got my cutting speeds and the thing is we got amperage here, PSI, material thickness, torch to work distance, torch to distance, optimum cut speed, and those are given in inches per minute and millimeters a minute. So I usually just cut mild steel. So these are all my parameters. You will have to check your parameters for your machine, and by doing that you would have to go into your owner's manual for your machine. If you don't have a cutting speed chart, you're gonna have to manually cut stuff, and you're gonna use a lot of material just to figure out your plasma cutting optimum cut speeds. So if you don't get a machine with this included chart in the manual, you're gonna have a tough time. So I always suggest shopping for something that comes with a lot of information and a cut feed or a cut speed reference chart. So I'm going to go ahead and I'm going to create a notepad here, which I've already done. I've gone ahead and I've listed all the parameters and everything off the cut chart. So the way I do this, I usually put the name of the plasma cutter that I'm using and the material that I'll be cutting. So this is PW from prime weld, S for steel. That'll be what I'll be cutting. And then my second will be the 16 gauge here, which is the thickness of the material. And then you want to enter your amperage for cutting that thickness. And then you want to put your PSI setting or your air setting for your machine. And then finally you want to finish that with the cut speed. So 110 inches per minute and 6,000 millimeters when you break it down into metric. So what I'll do here is I'll go ahead and I'll copy this and I'll show you why I do this the way that I created this. So when I'm going to go back to Sheetcam, and what I'm going to be doing here is showing you guys how to create this tool very easily. So you come into the tool section here, and this is where you're going to press this, which is going to create a new jet cutting or plasma cutting tool. So we're going to go ahead and go to the name that's here, and we're actually going to go ahead and we're going to paste all the information that I put from the notepad, and we're going to go to the type of tool, and we're going to be using a plasma tool here, and then we're going to enter the number of the tool. So we're going here with 1, and that's pretty much what I already have here. So on path rules, we're not going to enter anything here. Our machines don't really need to use this. This is going to be like really advanced or other kinds of controllers. So you don't need this. You need your kerf width, and you're going to be determining your kerf width by using your nozzle diameter. So what you'll have to do is you'll have to make a test cut, and when you do that you'll have to measure your kerf manually with like a caliper, a digital caliper. You just want to make sure that you want to measure it, and once you measure that you're going to input your value here. So we also have a feed rate, which is going to be inserted here, and this is why I do what I do with the title names for my tools. As you can see, I already have all the settings up here in the title name, so you can see feed rate 6,000 millimeters a minute. You don't have to go to another screen or look at your cart or your chart, your cut chart. Sorry about that. And when you have all your settings right here, that's what you'll be inputting right here. And you're not going to have a pierce delay because our machines already can adjust all that, and this software is not going to adjust any of these when it comes to importing or exporting the G code and running it through our controllers. So 0 seconds for the pierce delay. Pierce height, what I do is I just leave it at 1.5. As long, same thing with the cut height. Cut and pierce can be the same. And then the plunge rate, I leave at 3,000 millimeters. Again, it's not going to, you can set whatever value here, but the only difference it's going to ever make is when it comes to actually doing a drilling or a pierce drill or pierce peck operation. So cut height, just leave it at 1.5, and then pause at the end of cut. You're going to leave that at 0. You don't want any pausing, because if you do, what's going to happen is you might pause at the end of your cut part, leaving a really nasty exit on your part, or a really nasty pierce or end pierce. I get not end pierce, but it kind of looks like when you first do a pierce cut without a lead in, you'll have like a little dimple on your part and it'll look funny. And yeah, if you don't want any of that, just go ahead and leave that at 0. And then we're not going to use any leading settings here, because we're going to define that in our operations and not actually on our plasma tool here. And then lead in, just leave that as normal. So I'm going to go ahead, make sure everything's the same, and I'm going to push OK. I'm not going to do it. I'm just going to push cancel because I already have this inserted. So there's my tool. Your tool should pop up here when you push OK. Once you do that, now you have your tool ready and defined for your part. The thing is on your machine, I don't know what machine you guys have, but for whatever machine you have, you're going to have to make test cuts, and you're going to have to mess with the feed rates and the kerf width until you're happy getting, or actually once you make your test cuts, you're going to find out what your best cut feed speed is, or your feed rate, and you're going to come and manually adjust all this here. So it's actually depends on like what you use, whether it's a hand torch or a mechanized torch. They're going to be different, so they're going to have different settings, but this setting here, or this parameter, is for my hand control torch. So that is accurate, or as accurate, I guess. I can always change it if I need to. When it comes to inserting your part in that, I'm going to make other videos on how to do the rest of this, but this is how you insert your tool, and that you need to specify and add all your tools to your tool section here before you actually import drawings and start doing your cutting operations. So like I said, you got to go through your cut charts, write down or define all your parameters in the title of your tool. So going back to the notepad here, you can actually see the way I made it. This will make it easier from going from screen to screen, and or from manual to screen, and getting something confused. So this is the best way to do it. And not only that, but when I go into Sheetcam, I can actually come over here and I can see under my T1 or tool 1 the type of machine, the material, the thickness of material, the amperage, the PSI for the pressure for the torch, and then your cut speed. So yeah, I think that's the best way to do it. You can actually use other you can import from other sites that use, or other brands that use tool sets, and you can do that. But the thing is there's no tool sets defined for our machines, so you got to pretty much basically do all these manually, and just insert your parameters for the materials you're going to cut. As you can see, I only use about 7 materials. Yeah, the 7 materials that I use for cutting, or I mean 7 parameters for 7 different types of materials. And that makes it easier because, you know, different projects are going to require different thickness. I'm not always cutting 3/4 or 1/2 inch. And the thing is when I do have the actually have the parameter for it. So the thing is like this one here, the reason why I did like 1/2 inch with an E is for edge cutting. My plasma cutter is not going to pierce 1/2 inch material at the start. I mean, it will, but it's going to cause a lot of slag to get on the tip and it could damage it. So thicker material usually needs to be edge cut. And you're not really going to do piercing for holes and stuff on this type of thickness of materials unless you pre-drill and or you just really don't mind destroying your tip when it comes to trying to pierce such thick material. So my machine 3/8 is pretty much the pierce maximum. So 1/2 inch here, I use an E just so I can define that as an edge cut. That's when you're going to start your cutting at the edge. So let's go back to Sheetcam, and I think I'll go ahead and end it there. I'll go ahead and show you guys on how to import a drawing and do the operations on another video. So I want to go ahead and thank you for watching. I hope this video helps you guys, and I will see you guys on the next one.